the technical and socioeconomic and in the process that we go about to actually design something. And so here's that picture I showed you last class of us working in a field with a cotton farmer, trying to understand the requirements for an irrigation system. You might have noticed my 19th century steamer trunk up here. Any of you have me with 007 last spring? Okay, a few of you. Yeah. I like using this because I have a bunch of physical examples in here, and I don't want you to be distracted by them, right? So I don't want them just piled up here. And I think what better way to keep a bunch of examples than an old kind of eccentric steamer trunk from my grandmother's attic. But anyway, that has nothing to do with today's class. I think it's just fun. All right, so a couple updates. So I talked to you about Bob Hawk, Chief Mechanical Engineer from GE. He is confirmed. He is coming end of the semester. So that's great. You're going to be able to talk to Bob. And the last two lectures are going to be kind of, if you want to go commercialize your stuff, how could you do it through a big, multinational like GE or more of a small-scale startup? So we're going to have people talking about both those. Our two Tata Nanos, brand new, hot off the presses in India, are on a plane, literally, as we speak, coming to the US, coming to sunny New Jersey, and then they will get trucked up here. So they should be here very soon. And we're going to do kind of an autocross test day. So all of you, even those not on the Nano project, can play with these. So that's pretty fun. Okay, next thing. Did most of you read this, The Frugal Way? Yeah, it was really short, one page. What are people's thoughts about this? Yeah.
I had a very good experience on John Deere, Mexico, where we were always conflicting with the U.S. engineering headquarters because of requirements. We always wanted to do things quick and cheap.
Yeah.
Our supervisors in the U.S. were very, very reluctant and restrictive on how we did it in engineering. But the operations manager was always like, we want it now, we want it cheap, we want it this way.
The local operations manager.
Yes.
Yeah.
That pretty much summarizes my 2 years.
Yeah. I should preface this a little bit. Do folks know who George Whitesides is? He's one of the most preeminent scientists in the world. He's published well over 1,000 papers. Just think about that. His paper flow rate out of his lab. That's averaging over 30 papers a year out of a research group. It's just crazy. But for him to come out and say, we need science in this space is pretty cool. You had a comment?
I was just kind of wondering the difference between cost-conscious science and cost-conscious engineering.
Yeah, I wanted to bring that up actually. I think both exist, and I don't think, he makes a comment at the end that, maybe by bringing in economics into the science, it may not be what science is as we think of it right now. But I don't think that's true at all, necessarily. Science and economics aren't mutually exclusive. And one of the kind of examples that I like using now that I think kind of represents, I hope, where my lab is an analogy with Bell Labs at the beginning of the 20th century, right? Did I mention this the last class? Maybe? Okay, so what happened at the beginning of the 20th century is that AT&T knew people wanted to talk to each other across the country, right? But there's no way to make a long distance phone call. We didn't have the technology to repeat the signal without tons of feedback and stuff and get a good signal across the country. And so, AT&T may have been able to make a solution where they make this massive copper cable, dump a bunch of power into it, and maybe get a signal across the country, but that wouldn't have been economically viable, right? And they knew there was millions of potential customers. So what they had to realize is that they had to really push the science behind telecommunications, and thus they set up Bell Labs, right? And they also had to have an eye on economics. And a lot of the guys at Bell Labs were just kind of these mad scientist guys that we're not even necessarily thinking about communication, but they're in this environment to create technologies for communication. And AT&T was able to say, okay, how could we use this for communication? How could we make it economically viable? And so what came out of that was first the vacuum tube, right? And then the transistor, right? And those technologies revolutionized telecommunications around the world. And they won a string of Nobel Prizes out of it. So I think it's a very similar situation to what we have now in developing countries where, like I was talking about in the last lecture, that we have all these hard technical problems that nobody knows how to solve. economics is one of the requirements in them, but just the technology itself is really hard. I think that's a really good motivator for science. You have any other comments? Yeah.
Because the paper talked a little bit about resistance to this, but it seems kind of more on a theoretical basis. Is there a lot of general resistance to this idea? It seems, I mean, maybe just because we're in this space, we're in this class, it makes sense to us.
Yeah. I think times are very quickly changing. Like I think, you know, I couldn't have been hired probably 5 years ago. You know, I think like my timing worked out really well. I think people are realizing that these challenges in developing countries remain unsolved and are really, really tough to solve. And I've seen just over the last like couple years in conferences more and more and more research focused on developing countries, you know, like real hardcore research. And people like George Whiteside's coming out and saying, we need to do this stuff. This is why Rebecca Richards-Cornum's coming to this class too, because she's like a really hardcore scientist, but also really cares about this stuff. And purely as a coincidence, I wanted to put this up here, but today, if you go to mit.edu, this is a paper out of my group, right, which is talking exactly about this conversation, right? This paper, and you'll read this, by the way, in a week or so in the class. But what this paper is a big like detective story, like putting together a big puzzle of like what are the socioeconomic factors behind clean water in Indian villages and what they need, and what are the technical factors that are going to determine whether or not they work. And so, you know, we present this big case that really points at electrodialysis that's solar powered. Seems like it's really going to work. You know, so this paper just came out in the top desalination journal, right? You know, legit academic publication, but totally developing world focused. So I don't think they're mutually exclusive at all. Yeah, the timing of this couldn't have been better. It's great that it's today's. Okay, so let's now then go into the class projects and talk about those in some more detail. This is just a summary of what I showed last time. You can see the issue now with the class size. I think when you get really big teams, it's hard to get everybody to pull their own weight. But let's see what we can do. You know, stick with me. We'll see what we can do in the next 2 days before the next class. So anyway, you'll be connected with all your project partners once the teams are assigned, and you should be connecting with them, like emailing them, reaching out, having phone calls, like this week, at the end of this week, and they're ready for that. Okay, so I also wanted to make the point that like I really like thinking about being disruptive. I really like thinking about like how we can help these partners engage massive new markets that they can't engage right now. That's really exciting, and I like thinking in that disruptive mindset. In that I think all of these projects, we figure out a solution, it's going to open up some really big disruptive opportunities. You know, you may not create the whole technology, but you will set a trajectory potentially to get to a disruptive solution. Okay, to start out, the TATA project of reducing noise vibration in the nano, the mentor for that is going to be Jesse Austin Brenneman. He's a postdoc here in mechanical engineering. And so I tried to bring like physical stuff for each of the projects. I'm sorry, this is the weakest one out of all 6. Here's a little nano. If you want to see what a nano looks like up close, you can pass that around. Don't open the box. I want to keep it in the box. But anyway, I've got some other stuff to show. So anyway, with the nano project, one of the big issues with this car is it sounds kind of cheap. You get a lot of engine noise and vibration in the passenger compartment, and kind of the bench level of acceptable performance that Todd has said is Volkswagens, you know, lower cost economy car Volkswagens. And I would encourage this team to go drive other cars to actually experience the differences. The way Tata measures vibrations now is with accelerometers on the seat rail, the steering wheel, and the gear knob. And this is a really nice experimental setup that you guys can do on our nanos here. Right now, the car's pretty comfortable if you're cruising along at 40 or 50 kilometers per hour. The big issue is when you're at lower speeds, where the pulsations in the motor and the motor's not running as quickly make it uncomfortable for the passengers. People kind of equate like smooth feeling, good performance with a 4-cylinder engine. The Nano is a 2-cylinder engine. so the Nano's the cheapest car in the world, right? So obviously they're pretty cost conscious. They're also very weight conscious, because weight and cost are somewhat correlated, but they don't want to make it heavier. And like a problem, this relates to the Ferrari project too. A problem with the car industry is like as cars get better and better and better, they get heavier. So they want to think about ways to reduce weight, or keep the weight low, not increase weight. We have to be pretty cost sensitive. The price point they've put on this, or the cost increase that would be allowable, is about $50. They said ideally it would be around $25 or less. So we have to be thinking about kind of cheap solutions. They've played around, and the team that looks at this will talk to the Tata engineers. They've played around with structural changes, like changing the car's structure, the exhaust, the engine mounts, but they've only played around with stuff that's readily available in India. It doesn't mean you have to use stuff in India. They can import or make or whatever. And they've not tried any active noise cancellation, which is potentially an option here. Or Dynamat is an off-the-shelf product that we can buy here readily in the US, and it's a really dense foam that you will often line like the inner surfaces of a car, and it's a sound isolation material. But so this is kind of the mechanical viewpoint of the project. The whole other viewpoint they want you to look at is how to improve the quality of the noise. And so I have a couple videos here. Ooh, I hope this will play. I think it will play. Let me just check if this will play through HDMI. Really quickly. Sound. There we go. That should work. All right, hopefully this plays. But anyway, one example I wanted to show is the Fiat 500. This was a car from like the 60s that is two-cylinder. It was kind of cheap, so it's kind of like the Nano of the 1960s, but people loved it. So here's just a quick clip where you can hear the engine noise.
This car is clever, really clever. For example, the front suspension. It consists of just a single spring across the car rather than a pair. This isn't only cheaper, it's lighter as well. And that isn't some penny-pinching mash-up either. In fact, it's the technology that John Cooper used when he produced his brilliant post-war miniature racing cars. They say that there are 4 things that can go wrong with a Fiat 500. Mind you, there are only 4 things on a Fiat 500.
So you get the idea.
Its simplicity is its brilliance.
You could probably find a 500 here in Boston. I see them around sometimes. You might want to contact like the Lars Anderson Museum or something to see if you could drive one. But sorry for all the commentary and music, but that was the best video I could find that had the engine noise. Another engine noise that's really popular in India is the Royal Enfield. This is like literally a 100-year-old motorcycle that they still make. They've updated some of it, but it's kind of the equivalent of like a Harley in this country. You know how people like put straight pipes on the Harley and make it loud? The Royal Enfield's the same way. So here's a video where you can hear it starting up and hear it revving. But people love this in India. It's really kind of macho. And it's a single cylinder. It's not even 2 cylinders. Yeah, so you get the idea, kind of low and throaty. So the Tata Motors folks, I was talking with them last week, they're really excited about this direction of the project. Just totally rethinking like how could the Nano sound. Like one of the issues, I don't know if I mentioned it last class, is that it sounds a little bit like an auto rickshaw, right? Which are the little 3-wheel kind of cheap taxis that are not really associated with quality, right, or prestige. I think one of the issues on the Nano 2 is they used a 3-bolt pattern on the wheels, which is also what the rickshaws have on their front wheels. So it kind of makes it look cheap. But this could be a very cool direction for the project. All right, so the next one was looking at the feasibility of a home use electrodialysis system. And so I brought this because what's motivating this market is the desal, reverse osmosis market. And this is, be careful, this box is kind of falling apart. This is an example of a home reverse osmosis system. And you will go into a lot of kitchens. I think we can probably just pass around the main guts of this so you can get a sense of what it is. There we go. So that, would be mounted on your wall next to your sink and fills with water and desalinates it. So that's the kind of hardware we're talking about. And these cost like, 50 or $100 or so. Tata will tell you the exact price point of theirs, but they just entered this market. So anyway, give you some more background on this. The way reverse osmosis works, you guys, from high school chemistry probably talked about osmosis, where you have a semi-permeable membrane, and if you have a high salinity and a low salinity, they'll try to kind of balance each other out, and so you can actually get a pressure differential here. Sorry about the sound. Oh, crap. I don't know why this beeps. Anyway, I'll just point to it with my finger. Yeah, so what reverse osmosis does is you just use a mechanical pressure to drive it backwards, and you can capture all the salt here, produce the low salinity here, and this is your drinking water. But it relatively takes quite a bit of energy to do this in India relative to electrodialysis. This is the basis, part of the basis of the paper I was just talking about that we published. So what electrodialysis does is use an electric potential between a cathode and an anode to pull the salt ions out of the stream and collect them in concentrated areas here and here, and then you have more purified water in the sides. So it's just a different way of doing it. So the background of this is that there's a huge need for desalination technologies in India because 60% of the groundwater has salty water. So huge need. The big issue with RO systems like that is that only about 30 to 40% of the water that comes into the system is actually converted to drinking water. The rest gets thrown away. So if you're in a water constrained country like India, that's a big deal. Electrodialysis has up to 90% recovery ratio. And just like this point right here is, I think, the real basis of why Tata Chemicals thinks ED can be a disruptive technology in India. That's a huge selling point, that you're not throwing away so much fresh water. There's also an energetic justification that because of the salinity ranges in India, and this is covered in that paper too that I'll send out, that you need only about half the energy per unit volume of water you produce, clean water, for ED rather than RO. So it's more energetically efficient. The home use RO system market, like those things, is growing super fast at 24% a year, so there's big economic opportunities here. ED systems, why this is like a feasibility project, is ED systems right now are really only done on large scales, like in big plants. As far as we know, there's no like home use small scale systems. And so what this team's going to be looking at is, what would it take to make a small scale system? Can we shrink an ED stack down to that size? What are the trade-offs? Could this be possible? And ideally, like the final project here, the final prototype is like you take one of those, hack out the RO membrane, put in an ED membrane that you can make, because they're actually pretty simple to make, and see how it works. See if it desalinates as you want. The next project is the low vision magnifier project, and I brought some cool toys here. So low vision, a couple people asked me about this after last class. Low vision is not correctable by lenses, right? It's just like blurry vision. You can't put the vision into focus. So what people have to do to read is they basically have to effectively put the page like really close to their eye so they can see the letters. So you have like local magnifiers, and this is an example that you can pass around. This is an electronic one, and it's a pretty slick little system, but it costs over $100. So you have this little screen here that you can look at, and on the back side there's a little digital camera, and all it does is electronically magnify, so you can run this over your page and see the letters more clearly. the kind of lower cost issue or solution is something like this guy, which is an old school magnifying glass that you just put against the paper, put your eye up to it, you know, like this thing, and just read along, you know, and you can magnify quite well. So you can pass that around too. And then why this is a cool technology creation project is like you either have products that you can zoom up really close, or you have products that'll let you see really far away. So here's an example of one where you can see far away. A kid might use this in a classroom, and it's a little telescope, right? So you just, you know, I can see folks in the back of the room quite clearly with this. I don't know how many magnification it is. I think it's, I don't know. But you can try that out. So that's kind of the lower cost solution. Even that's like pretty expensive. I think that was at least $20. And then if you want something you can wear all the time, they have products like this. I'm going to give all these products to the team that works on this so you can play around. But you can get this. You can imagine this hurts your dating prospects probably, which is like, well, it works pretty well. It's really neat how this works, and it's actually adjustable. The magnification's adjustable. You can play with it when I pass it around. But you know, even if this works perfectly as a magnifier, the aesthetics aren't so great. They make you look goofy potentially, and that's an issue. And actually, people rarely wear these out in public. They said at LV Prasad, they'll mostly wear them indoors. You know, where they're less likely to be judged. So you can check those out. But anyway, to give you some more rundown on this project, and the mentor, by the way, is Nevin Hanamara, and the one for the one for the desal project, I forgot to mention that, is Natasha Wright, who wrote that paper, who's on the MIT homepage today. So she's super knowledgeable about water in India. So anyway, with this project, there's a massive global market for these products. You know, 50 million people, and it's actually much more common to have low vision than full-out blindness. So huge economic potential here. The distance type of tasks you'd be thinking about are watching TV, looking at a chalkboard for a kid, recognizing people like, you know, at a distance. Close, oh sorry, I meant to put a close distance thing here. Sorry, I left that out. Anyway, the target of this project would be a single device that's low cost and is passive mechanically that can both do near and far. And sorry, I switched the order here. The near task that we're talking about, you'd want to be about 40 centimeters away, and you want to do things like reading, writing, looking at your phone, that's a big thing, as well as using a computer. Variable magnification they felt is valuable. Our target customer, they felt, was actually a school child, because you think about a kid looking at a blackboard and then looking down at his notes, right? That's a big distance change really frequently. So that'd be ideal. And then the justification for a passive mechanical device is that actually a number of schools don't let electronics in the classroom, like even if they're assistive devices, which was crazy to me, but they said that's a big deal. That's a real issue in India. You need to understand in this project the physics actually between magnification and field of vision. Like when you magnify something big, you might not be able to see much of it. And like I was mentioning before, you want something cosmetically accessible. Yeah.
What makes this condition different than correctable glasses? Low vision is a different type of disorder than
Yeah, it's not a focus thing. It's not due to how your lenses are, you know, processing the image, basically. It can be something like, you know, a scratch or cataracts or, yeah, things like that.
So like sometimes your field of view is actually impeded.
Yeah, yep. Or it's just everything looks blurry, you know, because there's something screwed up with the image, not just because it's out of focus. Yeah. Okay, the next one is our project with Ferrari, conceptualizing a next generation hybrid transmission with them. And the mentor